Okay, so on power we can use the manual prefetching using GCC's built-in, and it will result in data cache block touch and data cache block touch for store, depending on the second parameter. On power and some other CPUs, it's possible that the hardware starts prefetching on its own. Say this is a sequence of cache blocks in memory, and the hardware doesn't know that we will access this, but say we get the cache miss here, and then a cache miss here. It will not start prefetching, but if it sees that there are 3 misses, and that distance is the same as that distance in bytes, then it guesses that we will probably skip that, and it should prefetch this one, starting prefetch like this. Okay, so if you use these instructions through GCC in the preflow push with an array, it's possible that you don't see any performance improvement, even though even if there are cache misses, because this prefetch facility can do the work for you without costing extra clock cycles. When could this cost extra clock cycles? When it prefetches things that are not needed, or the hardware doesn't know when we don't want to have data. It can prefetch too much, and it can overwrite useful things in the cache, and it can also, if all CPUs start prefetching like with this at the same time, it may overload the network, and the useful, normal cache coherence protocol messages will take longer time. So it's not automatically better to have this. There is another option as well on power, namely to prefetch up to 4 so-called streams. You can see them as arrays. And then we don't use cache blocks, because they differ between different versions of the CPU, of the power architecture. Instead, we say that we want a certain number of contiguous 16-byte blocks, and here we have, say, 4 16-byte blocks. So this is called a unit, and we say how many such units and the distance between them. And then this is typically programmed before a loop, if we can cover all the data that we need, unless, we can, if the loop is not too big, the number of iterations, then we can do this. And it will not be any instruction overhead in the loop, even if there are if the prefetches are pointless, because there are no cache misses. But I would not recommend doing this on the preflow push. That's just my guess, namely that this hardware prefetching will work sufficiently well, so it's just a wasted time to investigate this. That's just a guess.